Hello students, now we are going to start the conceptual questions criteria from the topic motion in a straight line. So let's begin the topic conceptual question. So first question is distance traveled by a freely falling body is proportional to mass of the body, square of the acceleration due to gravity, time of fall, square of the time of fall. The correct answer for this question is, students, we know for a freely falling body, unless specified the initial velocity, we are taking u is equals to 0. So freely falling body is an example for uniformly accelerated motion. From equation of motion, we can say h is equals to ut plus half at square. And if u is equals to 0, then h is equals to half gt square. When height is a constant because it is a freely falling body, so half g is equals to constant. So we can say h is directly proportional to the t square. Hence, we can say the correct option is option 4. That is a square of the time of fall. Next question is the numerical ratio of displacement to distance is always less than 1, always greater than 1, always equals to 1, maybe less than 1 or equals to 1. Solution. The magnitude of displacement and distance are equal only when body moves in a straight line without change of direction. In all other cases, distance is greater than magnitude of displacement. For that, we can say the correct option is option 4. If the velocity of the body does not change with time, its acceleration will be 0. The options are 0, unity, infinity, may take any finite value. Solution. Acceleration is equals to change in velocity divided by time interval, and a is equals to delta v by t. A is equals to 0. So, as velocity of body does not change, that means delta v is equals to 0. So, the correct option is option 1. Next question is, the acceleration of a moving body can be found from area under velocity time graph, area under distance time graph, slope of the velocity time graph, slope of the distance time graph. Solution is, if the acceleration of the body is a uniform relation between a, v and t, r, so v is equals to u plus at. From here we can say that as u is equals to a constant, so the equation is similar to that of a straight line not passing through the origin. So the graph between v and t is in straight line. Then the slope of the graph is dv by dt is equals to a. Hence the correct option is 3. The velocity time graph of a uniformly accelerated body is a straight line, circle, parabola, hyperbola. Let's move with the solution part. So the Vt is a straight line because V is equals to u plus at. The above equation is similar to y is equals to mx plus b. Hence we can say that the correct option is option 1. Next question is, a gun is aimed at a monkey. If the monkey falls under gravity, at instant of firing of the gun, the bullet will be pass above the monkey, pass below the monkey, hit the monkey, certainly miss the monkey. The correct answer for this question is hit the monkey. Next, two bodies A and B are projected horizontally from the top of the tower with different velocities at the same instant, with path of B as seen from A is a parabola, an ellipse, circular, a straight line. The correct answer for this question is a straight line. Next, which of the following has finite acceleration with zero velocity? Freely falling body at maximum height, vertically projected body, projectile, horizontal projectile. So the correct answer for this question is second. Next question. If the displacement time graph of a body is parallel to the time axis, the velocity of the body is 0, unity, equal to the displacement, infinity. So the correct answer is second. Next, a ball is dropped from certain height. It is an example of uniform velocity, uniform retardation, uniform acceleration. None of these. So the solution is body projected vertically upward at point of maximum height acceleration is not zero, but velocity is zero. Important point is that free fall body means only force acting on the body is a gravitational. That means it will be uniform retardation. Next question is three bodies A, B and C are thrown from the top of the tower with the same speed. A is thrown straight up, B is thrown straight down and C is thrown horizontally. They hit the ground with the speed VA, VB and VC respectively. Then VA is equals to VB is equals to VC. VA is equals to VB is greater than VC. VA is greater than VB is greater than VC. And VA is equals to VB is equals to VC. So here we can say, because first and second point will be similar, so it will look like that. Now move with the solution part. Slope of the distance time graph is dx by dt is the magnitude of velocity. So the correct answer is option 1. Next question is a coin falls faster than a scrap of the paper when dropped from the same height because for a coin. So the option is a gravitational acceleration is more, gravitational acceleration is less, air resistance is less, air resistance is more. Solution of this question is air resistance FAR is equals to MA and AR is equals to F air divided by M. So as the mass of the coin is more, AR is less. So A net is equals to G minus AR. For proper mass is less, so AR is more and A net is equals to G minus AR. So A net coin is greater than A net paper. For that the correct option is 3. 13th question is a lift is moving down with acceleration A. A man in the lift drops a ball inside the lift. The acceleration of the ball as observed by the man in the lift and the man standing stationary on the ground are respectively G, G, G minus A, G minus A. Third option G minus A with G and the fourth is A, comma G. So the correct answer for this question is the question number 3rd. Next question is the displacement of the particle along the straight line at time t is given x is equals to a naught minus a1 t minus plus a2 t square. The acceleration of the particle, this is the value of displacement. Option a naught, a1, 2a2. Next option is a2. Move with the solution part. So acceleration of the particle is a second derivative of displacement or d2x by dt2. So after differentiating we get this value 2a2. Hence the correct option is 3. So now the question is next one. We did this question already. Yes. The instantaneous velocity of a body can be determined by graphically, vectorically, and using the speedometer, any one of these methods. Solution is Instantaneous velocity magnitude can be found out by graphically from x minus t, graphical vectorially like by dv by dt, and by third speedometer. The correct answer is answer number 4. 16th question is a body starts from rest and moves with the uniform acceleration. The ratio of the distance covered in nth second to the distance covered in the nth second is 2 by n minus 1 by n square, 1 by n square minus 2 by n, 2 by n square minus 1 by n, fourth is 1 by n minus 1 by n square. Solution. Distance covered in nth second, Sn is equals to u plus a by 2 to n minus 1. 0 plus a by 2 to n minus 1. So distance covered in n second, S is equals to 0 plus half an square. Second statement. So taking 1 by 2 as a divisor, Sn by S, which is equals to a by 2 to n minus 1 by half an square. After solution, we get this value 2 by n minus 1 by n square, which is the option number 1. Next question. A stone is dropped from a height in a high wind. The wind exerted a steady force on the stone. As it falls, the path of the body is circle, straight line, parabola, or complicated to decide. Let's move with the solution part, students. The density of the stone is high, so the wind does not have effect on the stone. Hence, the stone moves in a straight line. So the correct option is 2. Question number next, 18th. The projectiles A and B are projected with the same velocity with angles of elevation 15 degree and 45 degree respectively. If RA and RB are the ranges of two projectiles, then RA is less than RB. So RA is equals to RB. The information is insufficient to decide the relation RA and RB. Fourth, RA is greater than RB. So the correct option is first. 19th question is a disc arranged in a vertical plane has several grooves directed along chords drawn from a point A as shown in this figure. Several bodies begin to slide down the respective grooves from A simultaneously. The ratio of their times of slide will be the ratio neglected friction and air resistance. AB is ratio AC is ratio AD is ratio AE. Second, 1:1:1. AE is a ratio with AD, is a ratio with AC, is a ratio with AB. And the fourth one is 1:2:3:4. So if we move with the solution part, the body is sliding along vertical diameter AC with cover the entire distance in time. TAC is equals to under root 2AC by G. And for an arbitrary groove arranged at angle, say theta to the diameter AC, the time of the motion is TAB is equals to under root 2AB G cos theta. Since AB is equals to AC cos theta, then TAD is equals to TAB. All these bodies will reach the bottom at the same time. This is the option 2. Next question is, a body is projected up with the velocity u. It reaches a point in its path at t1 and t2 from the time of projection. Then t1 plus t2 is 2u by g, u by g, 2u by g and u by g. Let's move with the solution, students. So as you can see, the ball start falling from t1 to t2. In this case, let's T1 and T2 be the time taken by the body to reach point A to point B. Velocities of the point A is VA is equals to U minus GT1. So time taken to reach point A, T1 is equals to U minus VA by G. If T is equals to time of ascent is equals to time of descent, T2 is equals to T plus T minus T, that is 2T minus T1. So T1 plus T2 is equals to 2T, which is equals to 2U by G. Option number 1 is the right answer. So next question, 21th is the average velocity of a freely falling body is numerically equals to the half of the acceleration due to the gravity. The velocity of the body as it reaches to the ground is g, g by 2, g by root 2 under root 2g. Solution, average velocity is equals to displacement by time. So u square by 2g divided by u by g is equals to u by 2, which is equals to g by 2, where u is the velocity of freely falling body just before reaching the ground. U is equals to g. Hence, the correct option for this question is G. Next, in the case of a body falling freely from a small height, the changes of position are equals to the equal interval of the time. The changes of the velocities are equals to the unequal interval of the time. The changes of acceleration is 0 in unequal interval of a time, all of above. Solution, when the body falls from a small height, acceleration due to gravity, g remains same. So, change of the acceleration is always 0, irrespective of the time intervals. Hence, the correct answer for this question is 3. Next question is, a man is standing in the lift, falling under the gravity. Release a ball from his hand. As seen by him, the ball falls down, remains stationary, goes up. Execute SHM. The solution is, according to the principle of equivalence within a given system without looking at other system, it is impossible to distinguish between physical effect due to the gravity and those due to the acceleration. Hence, the correct option for this question is 2. Question number 24 is, a body is projected up with a speed u and the time taken by it is t to reach the maximum height h. Pick out the correct statement. It reaches 3h by 4 in t by 2 seconds. It requires velocity u by 2 in t by 3 seconds. Its velocity u by 2 at h by 2. Same velocity at 2t. So A is correct, B is correct, C is correct, or D is correct. Students, for this question, let's move with the solution part. So time of flight, we know that T is equals to U by G, which is U is equals to GT. In time T by 2, the height reached by the body, H is equals to UT by 2 minus half G, T by 2 whole square, which is equals to 3 by 4 time of H. Velocity of the body in t by 2 seconds, which is equals to v is equals to u plus u minus gt. After a point, like we know u is equals to v is equals to u minus g t by 2. From here, we can say t is nothing but u by g, so u minus, again g will be divided, so final answer will be u by 2. Third will be velocity of the body, which is at h by 2. Applying the third equation of motion, which is v square minus u square, is equals to 2gh, which is equals to v square is equals to u square minus 2gh. V is equals to under root u square minus 2gh comes u square minus 2gh by 2. H is equals to u square by 2g. Hence, V is equals to under root u square minus 2g, u square by 2g is equals to u by root 2. After 2t, body returns to the point of projection. So, magnitude of the velocity is same, but direction is opposite. Hence, The correct option for this question is 1. So students, this is all about for the today's conceptual question. I hope you learned many questions and understand like how to proceed the questions. Thank you for watching this video.